Hey! Welcome to another video from Ready Set Drone. I am standing here today with Jason. Jason has built, what, 4 of these guys now?
4 of them, yeah.
4 plus a hexcopter. He's got some good build experience in the last year. Jumped into this hobby pretty enthusiastically. And he is going to tell us today a parts list that we'll need to build our own 250 racer, as well as kind of just some basics on the build. I am planning to build one. These are all my parts, which I've purchased, so hopefully I have the right stuff. And so I'm going to document that in a separate video, so you'll get to see me screwing things up and messing up solders and melting the
Burning
wrong things.
your fingers.
Yeah, blowing up batteries, all that stuff. But Jason's at least here to get me off on a good path. So if you're going to build your own 250, watch this video and learn from the master. So let's start with kind of what parts should somebody order if they want to build one.
Sure. Well, if you're building from scratch, which I highly recommend because it's quite a bit of fun, there are quite a few things you need, but it's relatively simple once you understand the core components. Obviously, we need some sort of frame. Most frames these days are made out of carbon fiber, and they look very much something like this. You'll see a lot of different varieties and shapes and some crazy stuff out there, but most average ones are shaped something like this.
And most racers are 250s. What does 250
250
mean?
millimeters diagonally from motor to motor.
Okay.
You'll see some that are 230s, some that are 210s, and then you go up to like hexes and 500s and 550s and that kind of stuff. But most racing size, they call it the 250 class. It's the most common size, and it comes out about something like this.
Cool.
I'd recommend carbon fiber. There are plastic frames. As I found out with my first one, there's a slow-mo video of it that's beautiful. Tried to flip it. Plastic's very brittle. This frame itself, I paid about $30 for. I've probably crashed it 30 times, 40 times. One crash for every $1 I spent on it, and it's never broken. The other thing too is you can find all plastic ones that are unibody, which is also a bad idea because those will
if an arm breaks,
the whole thing's gone, right?
Yeah,
And then
you got to be able to replace those arms.
Yeah, and all of these come with replaceable. And depending on where you order from too, take into consideration some shops sell the parts individually, which is really nice. Like if I just need to get a single arm, that's kind of a big deal. So I would keep that in mind. But definitely go with carbon fiber and try to find one where they have replacement parts in stock.
Cool. So that's the frame. The next thing would be what? The motors?
Yep, motors. Obviously, you need an engine. Now, motors come in different sizes and different speeds. They will have a kV rating, like you'll see 2100 kV, 2300 kV. That's how fast it's going to spin, depending on how much voltage you put into it. You'll see a second set of numbers, which is basically the sizes of some of the internal parts, the stator and that sort of thing. What it boils down to is sometimes they're different actual diameters, and the spacing of the little holes can be different. Most of these frames will have multiple holes on them and will adapt to most of this.
So you can put a different motor on a different frame.
Yeah, and sometimes some of these motors will have little adapter kits with it. Usually the frame will have a recommendation of the motor size, not the kV, but the second number, like 2204, 1806, that sort of thing. All has to do with the spacing and the size of the internal parts.
Okay, so you want to make sure that motor fits in there nice and snug.
Yeah, exactly.
So, and also question, are the motors basically hardwired to run clockwise or counterclockwise?
No, they are not.
Okay.
So all motors will have 3 wires, and the center wire is always going to line up. We'll talk about ESCs in a second. We'll always line up to the center wire there. The other 2 wires are reversible.
Okay.
So you can either reverse them that way. Some flight controllers are fancy, and you can actually reverse the motors in software, which is cool too. Yeah. But typically what I do is I always wire up the center wire, and then I will just use like some alligator clips and check which other 2 wires I need to hook up.
Spinning.
Yeah, and test it real quick, and then solder it all together.
And just as a build point, does it matter as long as diagonally you want the 2 diagonals to be the same, right? So the 2 diagonals do clockwise and the other 2 diagonals do counterclockwise.
Depends on flight controller too. Sometimes they're a little bit different, but as far as which one starts clockwise. But
okay, so it can matter to the flight controller.
Yeah.
And if you get that wrong, it's not going to fly.
Yeah, well, it'll do something. It's not going to go up. Your flight controller will come with instructions on the motor directions, and generally it's the topmost left one will spin clockwise, and then you just alternate as you go around the craft. But I have seen a little different with hexcopters. It's obviously very different. There's different configurations you can put them in. So you have to consult the manual. So as you're wiring them up, the first thing you want to do is make sure you've read the instructions for your flight controller and make sure you have the motor directions done correctly.
RTFM.
Yeah, exactly.
Okay, so that's motors, that's frame. What about these elusive things called the ESC? ESCs.
Yes, yes, the escape keys. These are electronic speed controllers. Now, these have 3 connections on them. One end actually wires up and solders up into your motors. The other end actually solders into your power. We'll talk about the power distribution here in a second, but you've got 2 wires that go to your power. The third one actually go to the outputs on your flight controller. And so essentially these sort of act as your governor. These are taking power and power from the board and signals from your flight controller and controlling the outputs to the motor. And this is what makes it go. This is your transmission, your governor, whatever you want to call it, right? This is where the magic sauce is. They will have ratings as far as how much amperage that they can handle. Generally for these size quads, like a 12 to 15 amp is ideal. They get larger as they go up, so if you throw a 20 or 30 amp on there, it's gonna be a big, ugly, bulky build and overkill. Yep. Some of these will be rated for 12, and sometimes you can push them a little bit higher.
What is that one there?
These are rated at 12 amps, but
Okay.
they're nice and small, so they're going to come out nice and clean when you put them in the build.
These are the ESCs, right?
Yeah. And you can sometimes put them inside the craft, that as I've done with this one. Sometimes you can put them, most people put them on the arms, but you can also put them inside the craft. You probably don't ever want to stack them. They do get hot, and they do need a little bit of airflow. That's why it's really...
it kind of makes sense that each ESC would go out towards its motor.
Yeah, and that's why it's kind of popular, because it gets lots of airflow out there. It's a little easier when you're putting it together. One of the trickiest pieces is doing a really nice clean, I didn't do a fantastic job here, is doing a nice clean solder between them. They wind up being very close together, your motors and the wires for the ESC. This one was nice because I put the ESCs in here, and so that gave me a little bit of room. And sometimes people will put mesh wrapping around. It makes it look really nice. That's the tricky part. You don't want a lot of bulky wires in there, so you wind up trimming your motors down quite a bit. And stripping the ends of the wires to get a nice clean solder.
You need a wire stripper.
Oh yeah, definitely.
Soldering iron.
You can do it with a pair of scissors if you're crafty, but it's
Speaking of
harder.
solder, I know there's different types of solder. Is there a particular type? Is it just the generic wiring electrical solder?
Yeah, that's
Okay.
pretty much what I always get. I mean,
Get it at Home Depot or whatever.
Yeah.
Okay. So let's talk a second about props. Obviously you need 4 propellers, 2 clockwise, 2 counterclockwise.
Yep.
I know there are different numbers that there'll be like 645 or 530. What do those numbers mean on a prop?
Absolutely. So the first part of that number is the length of the prop. So a 5.0 is a 5-inch, 6.0 is a 6-inch.
Okay.
Generally on 250s, you can use 5 or 6. It really depends on how the build comes out. Like this guy here, the arms are actually a little bit tighter in.
So yeah, you can see you couldn't fit any more on there.
6-inch would be a stretch on
And
this
these are
guy.
5s?
Yeah, those are definitely
These are,
5s.
what do they say, 5?
These are 54.
50/40s.
50/40s, yeah. So again, it depends on the frame. Will also usually tell you whether it'll accept a 5 or 6-inch prop. Most people go with 5-inch props. These are another variable you can just have fun with and tweak. They have different properties, obviously. The pitch, which we'll talk about in a second, but the length all affect the amount of thrust and the load it's going to put on the motor. So you can generally play around with that. Smaller props generally will spin faster, obviously, because they're lighter and they have to work less hard. So that's a consideration. If I want large props, I'm going to be putting some strain on my motor and that sort of thing. So it's just a consideration. The second 2 numbers are the pitch of the props, and when I mean pitch, I mean the actual angle of the props
Usually
themselves.
35 or 40 or 45 or 50.
You see 30s, 40s, 45s. I don't know if I've ever seen a 35. And it's inches, so it's a 3-inch pitch or a 4-inch or a 4.5-inch. It's really about the angle of it, and also this affects the flight properties. Something that's angled more steeply is going to move more air.
Okay.
And will go faster, which
more
in turn
aggressive.
is more aggressive, exactly.
So as a beginner, you probably want to start with
50
a less...
30s.
Yeah, 50/30s or 60/30s are a great starting
Yeah, most
point.
common, Gym Fan is the most common manufacturer. They're pretty inexpensive, a couple bucks for a set. The last thing you'll see on there is a letter. You'll see an R or an L, or sometimes just an R and no L. This has to do with whether it's what's called a pusher or a puller. And this is the direction that it's going to spin and which way it's going to push the air. An R is a pusher, and the easy way to remember it is it turns right, it turns clockwise, and it's going to push air down. A L, or just missing, is going to be a puller. It's going to spin the opposite direction.
left.
Yeah, exactly.
Okay.
Exactly.
Yeah, so that helps you differentiate. You'll also, the more you do this, you'll learn to look at them and just see the difference. But I actually put all of my props on a racer one time, all of them upside down, but in the right positions. And when I say upside down, I don't mean so that it was pushing into the ground. I mean so that it was basically turning the wrong way. It flew, but barely. It was the weirdest thing. It took off, and I was like, something's not right. And then I realized I had put them all on upside down.
Know
so
quickly if you've done
attention.
it wrong. It'll just flip over. One side will start to lift. And
Yeah.
It'll be pretty obvious pretty quick.
So power distribution board.
Yes.
Let's talk about that for a second.
This is nothing fancy. At least this particular version is nothing fancy. Usually these are separate. Sometimes they're built into the board. All this is there for is to take the incoming current from your battery and give you some nice solder points to be able to send it to other things. You wind up soldering on at least 4 other things, your ESCs, but typically you want to solder on maybe additional wires for LEDs if you want to look cool, or if you have a camera and that sort of thing.
So in this case, this has that, what'd you call it,
It's a Dean's connector, yeah,
so,
which is,
so,
you
so
won't be using that.
I'll have to solder an XT60
XT60
onto this so that it'll fit onto the
Yes,
battery.
yep,
Okay,
yep.
But this is basically where the power is going to come
and it's
from.
just designed as a convenience. I mean, theoretically, you could actually wire up everything in one giant glob of solder to the end of your battery, but that's ugly. And you get these little boards because typically what you can do is you can sort of put them in between 2 pieces of your frame. You can see here, most of these frames have 2 pieces on the bottom. So typically these can go sort of sandwiched in between there, and you can run your wires out from them. Some frames are fancier and have that sort of thing built in. This is a Red Rotor Strider frame. It actually has all those electronics and everything and more built into the frame, so they don't need a power distribution board. This one's nice. It's got on-screen display, a buzzer, all sorts of cool stuff. They do tend to be more expensive.
Yeah, and just, as a point of thought, if you're going to build your own, I had actually started off, I was going to buy that same thing because I usually copy what Jason does. But then I thought, well, you know what, I should probably start with something pretty cheap. And so this is actually a pretty cheap frame.
Yeah.
Build it first, make all my mistakes, crash the thing. It's not, I'm not a bad pilot. I can fly the thing. It's more the build that I'm concerned about. So I started off with something cheap. So that's my recommendation. Start off with something easy.
Yeah, this frame I got from a place in San Antonio, and it was $30.
Yeah.
And they sold the pieces individually, and I bought 2 when I ordered it. I'm like, at that price, I know I'm going to crash it. I know things are going to go horribly wrong. I wouldn't go all out until you're a lot more comfortable about how you crash, right? So yeah, that's a good bit of advice.
So flight controller. Let's talk about that.
Yes, the engine, the brains. That's the important one, right? So obviously all these have to have some sort of flight controller to run. They wind up being a little tiny circuit board that looks something similar to this, with a bunch of connectors on it.
Now, which kind is that?
This is the CC3D.
CC3D. Okay.
There are 2 very popular brands. CC3D is actually a more controlled brand, and it uses a software called OpenPilot for its firmware and the software used to manage it. All of these boards wind up doing the same thing, right? They have inputs and outputs. They have a little microcontroller in them. They have a 6-axis accelerometer. Some of the fancier ones will have a compass or a barometer if you want to try to check your altitude and that sort of thing. Some of them have GPS, like have connectors if you want to put a GPS on there. Most people don't do all that stuff with these 250s. I mean, you put these things because you want to fly them with goggles and, look awesome. And you don't need all that stuff. You don't really care about it. That's usually when you get into much bigger ones and you want to do something fun like autonomous and know exactly where you are.
Okay.
So generally, you can go with kind of the lower end. They'll typically offer 2 versions of these.
Does that run about $40?
$40 to $70. The other big one you'll see a lot of is what's called a Naze 32, and that's really the type of microcontroller that's in it. But there are different versions of that. So there's like knockoffs of it and different brands.
And that's made by DJI?
No. Naze 32. There's different vendors that make it.
Oh, they make the NASA?
Yeah, exactly. And so the differences are in the software that you use to manage it. There's different camps. Like some people like one better than the other. We can go into a more detailed discussion on that later. They both do the same thing. I've flown and used both, and they both work about the same.
Okay.
Typically, the Naze 32 ones are a little easier to get started with. You can get them a little cheaper, and the software is just something that runs in your Chrome browser. It's a little easier, a little more intuitive.
Okay.
So I'd probably recommend that, but they're both very good boards.
Okay. So I picked the harder one to work with.
But it's worth it. Okay. And you've got a little case with it. Sometimes they come with a little hard case.
Yep.
These guys wind up trying to go somewhere usually in the center of your build. Sometimes, like with a case, you can just stick it down with some 3M sticky tape. Sometimes they have little plastic mounts where you can actually mount it to little holes in the board and that sort of thing. But generally, you want it in the center of the board because it does have that accelerometer, and you kind of want it, in the middle of what's going on.
Even.
Yeah.
All right, so flight controller. We talked in our last video about LiPo batteries,
Yep.
and obviously 3S is probably the way to start.
3S is a good conservative way to start.
With the XT60 connector on the end
Yep.
and the balance charger.
Yep. If you want to go crazy and eventually do 4S, just take that into consideration in the parts you're buying. Do a little research and see if they've been rated for it. A 4S is going to fly faster. It's a lot more fun. It's also scary.
Yeah.
So
start with the 3S.
Start with the 3S.
Plus the 3S batteries are really common and cheap. And,
Exactly.
So then for the FPV part of this whole deal, you need to have your camera and your transmitter. This is just one of these standard little, you got one on there.
Yeah,
or
little
on
security
here.
cameras.
Yeah. It's called a Run Cam. I got this on Amazon, and this one has a plastic housing, and I suppose I could take it out.
Yep.
Has a plastic housing, and it has a adjustable. This was part of why I bought it. It's supposed to be able to be tilted up and down.
Yeah, depending on how you mount it. Sometimes these are tricky because depending on how they fit in there, sometimes the adjustment doesn't even work well because it winds up getting wedged between them. So it's a little tough. You'll find a lot of these out there. They started as like little Sony security cameras, for businesses or whatever. Now they've mutated in this world. So if you search for FPV camera, you'll find a ton of these. Like you said, you want ones that either have the plastic housing,
They're lighter.
or ones that don't have the housing at all. If we can move that prop out of the way, that's just the circuit board in there. The reason being is you do find some of these that are really heavy. They come in a metal housing, and like they're just, you can feel it
Makes
in
it
the hand.
nose
It's ridiculous.
heavy.
Yeah, and it just adds weight to your copter. I mean, the lighter you can get it, the better it's going to be, right? But these are all extremely common. Most of them will run off of a range of voltage, generally 12 volts, but a range there. And yeah, they're pretty expensive, $30-$40 for a decent one.
This is the RunCam 600.
Yeah, I wouldn't recommend.
TVL.
There are some other branded ones that are like really crazy expensive. It's not really worth it. They're all about the same resolution. They're all like CCD or CMOS sensors. They're all 600-700 TV lines. They're pretty low fidelity.
Yeah, they're really just to show you where you are and help you fly.
Yeah, it's like watching a bad VCR tape through your goggles, but that's how everybody's is, so don't feel bad.
But for the actual recording, if you're going to fly and actually get recording, I'm a big GoPro guy myself, but I invested in a $80
These are fantastic.
Mobius. These were originally designed to be, I think, car cams, like
like dash
cams.
cams or
But
bicycle or whatever.
The big thing with the Mobius that is nice, and I actually think the Mobius is in the other room. It's not in the box, but they're very flat.
Yeah,
and so
they're
they have
flat,
a low
they're
profile. You can see both these have a Mobius mount here, which comes with it, and so it just basically clicks in there.
Yep, I just glue that down with some sticky tape. Sometimes I'll put one of these around it. I do find that even though it mounts in there, sometimes when you have a really wicked crash, the thing will fly off. It makes for a great video, but
and the Velcro strap might be a way to
I usually
or a
use
zip
a Velcro
tie
strap
or
or
something
zip tie. Yeah, exactly.
that you can put in there.
But they're fantastic. They're really good quality. I highly recommend them.
They do 1080,
1080p,
30
frames a
frames.
second.
Yeah. So it's it's not going to be quite as good as a GoPro, but it's also a third or a quarter of the cost.
Yeah,
and so,
they're fantastic.
Okay, so
Now, I will say on that too, some people actually do use those as their FPV cameras. I wouldn't recommend it. I tried that for a while. It works. There's just a little bit of lag. So you wind up with two cameras. You wind up with an FPV camera,
Right.
and then you wind up with some sort of recording camera if you want to go all the way.
and I kind of skipped over the transmitter. So basically, this device transmits the signal from your FPV camera to your goggles.
Yep.
Right. And so one mistake or one problem people can have is these transmit at. There's different frequencies they can transmit at, and there's Boss Cam, there's Fat Shark. I think there's a couple of other frequencies, and you have to make sure that whatever your goggles are compatible with the transmitter.
Yeah.
Correct?
There's this is a 32 channel transmitter, which is nice. And essentially, what you'll hear you'll hear it referred to as different bands. There's basically 4 bands.
Like A, B, C, D.
And there's it's just a range in the spectrum. They're all 5.8 gigahertz, and there's 8 channels in each band, and one of them is like the Fat Shark band, and that's like their default module that comes on their goggles is those 8 channels.
Right.
The others, there's like 2 Boss Cam ones, and then there's a third one, I forgot what it's called. They're all just part of these 32 channels that are spread out. So these guys are really nice. It's the TS-832. There's an 851 or 2 that's a receiver for it, which is really cool.
TS-832. What's what's wrong with your transmitter?
Exactly. These are handy because I believe this one has an LED readout on it, which is really nice. A lot of these guys will have tiny little dip switches, and they're a royal pain in the butt. These are worth it. They're a little larger, but the LED is nice. You can just push the buttons. You can cycle through all 32 channels, and if you have a receiver, again, there's a Bosscam model that is almost identical to this, except larger for a receiver. You can just easily line up the number, or you just make sure you buy the right module for your goggles to line up with what you're transmitting.
And Team Black Sheep makes a module that I put into my Fat Sharks that works great.
Does all 32 channels, and there's a generic one for the Fat Sharks that do all 32 as well.
Nice.
So those are really handy. And then, of course, some antennas is important. You don't want to run these things without an antenna plugged into them.
Very important.
They will heat
overheat
up and die.
Yep. So even if you're not using your goggles, don't take the antenna off thinking that you're saving weight or something. Leave the antenna on, because this without an antenna is basically not able to dissipate its signal anywhere.
Exactly. It'll heat up and burn up. These are nice. They're these little clover ones. You'll see some that have like a little mushroom plastic cap on top of it. It's the same thing. It's just these guys inside it. I wouldn't recommend those. Those things come off all the time and break.
Yeah.
And these ones that are just kind of out in the open and bare are really nice. You can do some neat things with it. You can do a right angle, and you can put it on the back of the model like I have here. You can also get an extension and maybe have it sticking up from the top if you want to go
And
that
by the
route.
way, Jason, these are for you.
Oh, because you stole all mine.
Because
Thank you.
I have broken lots of
Every time.
antennas.
You got an antenna?
So I have it here on camera that
All
I've
right,
repaid
it's
him.
documented. Thank you, sir.
So last thing that I think is absolutely essential, and we'll get into the non-essential. Obviously, you need a radio, a transmitter, controller kind of thing, and then you need to find the appropriate receiver for that. So Spectrum, I happen to have the Spectrum DX6, and it is decent little radio.
Those are nice.
And the Spectrum receiver is right here. I'm a little confused. The bind plug, I believe, is what you use when you first bind the two.
Yeah, it's just a jumper.
And then you pull the bind plug out, and then you don't need it anymore once they're bound.
Yeah,
right?
you jumper 3 of these pins, and that's all that's for. Some other receivers will have a little button you hold down to bind it. It just depends on the model.
Okay. So tell me about wiring up the radio receiver to the flight controller.
The flight controller will the CC3D has actually a special cable that has a single connector, and it breaks out into 8 different servo connectors. Some of the NACE32 boards have the same thing, or sometimes they just have pinouts that just wire up 1 to 1. So you would have one for each motor, which essentially will be a channel 1 through 4,
right.
And then you'll have a 5th channel usually for flight mode, so you can rig up a switch over here and switch between
and you do that in the software.
Crazy and non-crazy, exactly.
Okay.
Some of these do support, depending on your receiver and that you're using, what's called PPM, which is a different type of sort of protocol that these things use to communicate. And in that case, you actually don't need more than one wire. You can actually wire everything up through one wire, and it does all channels over that single wire.
Okay.
Yeah, it's really, really cool. So I don't believe a lot of Spectrums do support PPM. There's like adapters that allow them to. But that's something kind of cool to take into consideration too, because then it makes your wires a little bit cleaner. You can hook up the one wire, just snip all the other ones, and you do everything over a single wire.
How do you know which one of these connectors goes with which one of these goes into which one?
It will be it'll be probably color coded in the manual, but you can actually look at, in the case of the CC3D, you can look at the little connector it's got here, and it's kind of from left to right. So I think usually it starts with like a red wire, red, black, and white on the left-hand side, and that's like channel 1 with power, and channel 2 and 3 and 4 and 5. But again, it will all be in the instructions. Either if it's breakout pins on the board itself, it'll be labeled 1 through 8. Or the instruction manual will tell you which ones go to which.
I almost feel like it would be better to not, really clamp anything down. Put the motors together, put the bottom of the frame together, but then get everything plugged in and tested before you do any shrink wrapping or taping or.
Yeah, I wait to zip tie everything until I'm all sure it's working. Because I've made that mistake many times. I've shrink wrapped or heat wrapped and zipped,
great.
and then one motor doesn't work.
Right,
and it's just
right.
like, oh god. That's definitely good advice.
Okay.
But that's the last piece, and then you put on the top and clean it up, zip tie it, and the rest is just testing.
Yeah, and then I guess you want to make sure that your center weight is kind of centered.
Much as possible. Yeah. So you see some boards that will actually have their batteries mounted way back here.
Yeah.
It still works.
My Helipal's like
yeah,
that.
but you ideally it should be leveled out as far as the weight's concerned. So most people fly with their batteries on top. But in general, the more stuff you can put inside the frame, the better, because you are going to crash a lot. And my Mobius used to fly off all the time, but it's never broke. And your battery, is going to take a beating regardless. So it's just something you have to get used to.
Awesome. Well, if you have questions or comments about building your own, please leave them in the comment section. Please be sure to visit ReadySetDrone.com. We have some cool t-shirts. We have some cool merch. We're trying to put more and more content up all the time. Be happy to put up your content if you want to send it to us. And definitely subscribe to our channel, the one you're watching right now. Jason, this is great. I am planning to document this whole thing and probably lots of Skype calls.
Probably
and,
borrow some more antennas.
Yeah. Well, no. I'm good. Look, I gave you back your antenna, right? Ultimately, though, I think it's going to be a lot of fun to build this thing and actually be able to fly one that I built. I have a Helipal right now. It's great, but pretty much I cheated, right? It came straight out of the box.
It's rewarding. It's fun to build it yourself.
Yeah, and have a little bit of fun with this. So again, thanks for watching. Hope you enjoyed it, and we'll see you in the next video.